So, hello everybody. At least we made it. Due to the career day yesterday, I again had to postpone some lectures and therefore please participate and show your preferences that we can yeah, hold the lecture in the beginning of December. Okay, then we have started the theoretical part and we are at the point that we want to relax some assumptions or in that we want to be a little bit more realistic. We started with the Keynesian commodity market, and last week then we started with the so-called ISLM model that we are adding the money market. Remember our topic, our chapter when we have talked about money in general. Money is essential for developed economies, so a good model has to incorporate the money market. And with the money market, we have introduced money demand as we have seen it in the chapter talking about money. And there we have done a new variable, a new endogenous variable, the interest rate, and this interest rate is now coupling both markets, the money market and the commodity market, because we introduce now also an interest rate dependence of the investment level, and we argued in general that money demand due to the speculative motive or the opportunity cost argument that this is negative in the dependence on interest rates, and in the same way we also discussed the dependence of the investment level on the interest rate, and there we had also this opportunity cost argument that we have an investment opportunity, and especially the interest rate or the interest rate level within our economy is somehow the price of a credit. And if we have to finance our investment via credit, then of course the investment will be more expensive if the interest rates are higher within our economy. Or taking the so-called Keynesian investment hypothesis, where we discussed the so-called marginal efficiency of capital. And this you have hopefully, or the argumentation, you have hopefully already seen in your math course or in your investment course, that we in general think we have an amount which we have to invest. Think within a company you want to buy 10 new laptops or something like this, an investment of 50,000 euro, and you have some expectation what will be the return of your investment in the future, and these returns after 1 year E1, after 2 years E2, and after 3 years E3. And then of course the argumentation is not that you only add up your future expected returns on your starting investment and then decide if the future returns will be larger than your starting investments. You will do the investment, but you have to keep in mind that these are future returns. So then you ask again yourself, in order to obtain such a future return, you ask yourself, how much have I to invest today in order to obtain at the capital market, for some specific interest rate today in order to obtain this future return. And in the other way around, then by dividing by this interest rate factor means that this number E1 over the interest rate factor 1 plus I is the value of a future return today. And then we say, okay, let's take this calculation for all future returns. And for the future return in 2 years, then you have to divide by the square of the interest rate factor, in 3 years by the power to 3 of the interest rate factor. And summing all these up would be then your present value of these future returns. And then we ask, which interest rate do we need that the present value of all future returns just matches our today investment. And then you have an equation in this variable I star. Then you solve for this I star, where just the today's investment equals the present value of future returns. And this interest rate we call then the internal rate of interest, or in this macroeconomic interpretation, the marginal efficiency of capital in general. And of course, then it is a similar argument compared to this opportunity cost argument. We argue if this internal rate of return I star is larger than the capital market interest rates, then we invest into this investment opportunity. And in a macroeconomic point of view, we then add up all investment opportunities where the marginal efficiency of capital, I star, is larger than the general capital market interest rate. And this again means the higher the interest rate of the alternative at the capital market, the lower is the number of investments which we are doing today. And again, we obtain this negative dependence on interest rate. Okay, so what we have now is we have a total demand, still this Keynesian total demand, YD equals C plus I plus G, consumption plus investment plus government expenditure. But now our investment is depending on the interest rate level of our economy. And this means now we obtain now a dependence between the total income of our economy and the interest rate. And this we will do now, and this is called the IS curve. For this, we again start with our diagram. Oops. Which we already know, Keynesian commodity market. yd on the vertical axis and y on the horizontal axis. Again, we draw our equilibrium condition, yd equals y. Condition. And we introduce our total demand, yd equals consumption. And now comes the difference plus investment. And in order, and since we want to draw here an explicit function, we have to know this investment level, but we know that this investment level is depending on the interest rate. But in our diagram, here, yd and y, we do not find the interest rate. So in behind, we just assume that we know the interest rate. So we assume interest rate I should be fixed at some level I1. Maybe this is 4%, just a fixed number. If we know the interest rate level, then we also know the investment level, plus government expenditure. Where do we also find this investment level? Well, here at our cut of the vertical axis. This was C0 plus now investment level depending on the interest rate I1, a fixed number I1, plus G. And then we argued, okay, the cut of our line representing the equilibrium condition and our specific total demand function, demand-driven model, production is following the demand. The cut of these two lines is our overall equilibrium at the commodity market. So we obtain here our equilibrium income level, Y star, but in the beginning we have assumed a specific level of interest rate. So this equilibrium income level is now also dependent on the interest rate, I1. And in this argumentation now you have to be quite careful, because now we are really starting to think in variables. And this is actually not easy. You find some funny videos explaining all this in 5 minutes. But please think slowly about it. Because I cannot do always this, the explanation given always examples, giving specific functions and saying always, well, the interest rate level is 4%, is 6%, and so on, because we want to deduce here a general dependence. And for this, you really have to think in variables. And this is what theory is about, that we can argue in general about dependencies, and that we not always have to give a specific example. So then let's go on. Now here we have our equilibrium income, but now depending on an interest rate. In general, we want to end up with a dependence between interest rates and income, but a general dependence. So we now turn to this diagram where on the vertical axis we put interest rates and on the horizontal axis we still put the income. So this means we can just go down into the other diagram and put here just also our equilibrium income derived from the commodity market diagram above. But here again we have this interest rate level I1, maybe 4%. So on the vertical axis we then just put this number 4%. This is somewhere, this is some level on the vertical axis. So we just assume it would be here. So then this cut here we can also represent in our interest rate income diagram, and this would be then at this point. So this is one possible pair of interest rates and income where the commodity market is in equilibrium. And now comes the next step. Since we want to have a general dependence, now let's assume we would have another interest rate level. So in our head, we are now changing the interest rate level. And let's say this interest rate level would be larger than our starting interest rate level I1. And now my question, what will now happen in our starting diagram YDY, the commodity market, if we change the interest rate level, if we increase the interest rate? Has anybody an idea? Yep. Pardon? The price. Now we have a new situation. I2 or interest rates are increasing. Then something has to change. What is changing in our above diagram? But first of all, the answer. The price is changing. What would your fellow students say? In what kind of model are we here? Keynesian model. What is the one of the main assumptions in a Keynesian model about prices? Yeah, the prices are fixed. So this is really a wrong answer. Of course, in general, prices will adjust. And I said that many, many times, but now we are arguing within a specific model, in a short run model. And there we say, well, the speed of adjusting prices is quite slow, especially in labor markets. Labor is one of the main input factors. This is what changes production in the end. And there prices do not adjust. So please be really careful. We have to argue within the model. And here, I really said this many, many times. The starting slide. Prices are fixed. Then we move to the ISLM model. And again, prices are fixed. We even, until this description, we even haven't seen any variable of P. So, prices cannot change. But what is changing in the commodity market when we change interest rates? The internet can also participate. Yep. Yes, the investment and the direction is also true what you have said. The investment is lower. Opportunity cost argument. Well, the alternative is, so to speak, now better. Not to buy new laptops, but just putting the money to the capital markets. And of course, also this marginal efficiency of capital is now compared to the higher interest rate level lower. So we will invest in a lower number of investment opportunities. So this means investment level is decreasing. So we have I of I2 is lower than I of I1. So something has to happen to our total demand function. And what happens now if the investment level has decreased due to an increase of interest rates? We find it, of course, here in general in the demand function. And where have I also written the investment level in the upper diagram? The prices are still fixed. Please do not change prices. We even don't have a P until now. Yeah, yeah, yeah. Yes, of course. Yeah, this is then the next step. Here we have also our investment level. This is also part of the amount of the cut on the vertical axis. Let's assume this level would be 200 billion euros and now it's only 80. So this decreases. Then the cut would be maybe here. This is then C0 plus I of I2 now plus G. The slope is still the same. The marginal consumption rate we haven't changed. So we obtain then a parallel shift of our demand curve. This demand curve is now C plus I of I2 plus G. And then, this was your point, now we obtain also a decrease of the equilibrium level. The cut of our equilibrium condition and our new demand function is now moved to the left. So this is y of y star of I2. And then we are doing the same as before. We go to our interest rate income diagram, putting our equilibrium level down here, y star of I2, but we have assumed that we have a higher interest rate level. So I2 has to be larger than 1. Let's put it here. Let's say if this one is I1 would be 4%, I2 is 6%. So this is I2. So this then would be another possibility where commodity market is in equilibrium. And now comes the general thought experiment. Well, this we have to do for all possible interest rate levels. So then let's do it verbally. What happens if compared to our starting interest rate level I1, we would decrease interest rates? I3, which is now lower. Let's say the starting level interest rates are 4%. Now interest rates should be only 2%. Yeah? Yes. So YD would then move upwards. Then we would obtain a larger income level. We go down here. We would have a lower interest rate. So somewhere maybe here, we would also obtain another pair of interest rate and income where the commodity market is in equilibrium. And this we are doing not only for I1, I2, I3, but now further decrease interest rates. Then we would be maybe somewhere here, or further increase interest rates. Then we would be here. Putting all together, we obtain a general dependence of interest rates and income. And these are now all possible pairs represented by this curve, interest rate income levels where the commodity market is in equilibrium. And this new derived curve we call the IS curve. And the name again, IS curve, comes from the condition that I equals S is the same condition if we would say Y equals YD. So this is the perspective from the commodity market. Now we move to the money market. We have qualitatively introduced. And now at the first time we will introduce the variable P, prices, but at this step of our theory, we still assume that this number P is fixed. I introduce it right now because later on, then we will flexibilize prices, and this will be one part in our theory where the price level feeds into our theory. But still again, please, in this ISLM model, do not argue that prices are changing, because the main assumption, one of the main assumptions, is that prices are not changing. Okay, what we assume here, we assume, and a little bit we have talked about this, talking about money and monetary policy in general in our descriptive chapter, that we now make the assumption that the central bank can really steer the nominal monetary aggregate. And remember again, we said more or less the base of money is the amount of the balance sheet of the central bank. And then we introduced this money market multiplier. We defined M2 and M3. But now we assume that in general, we somehow know how this money market multiplier is functioning, so that in general we can steer the amount of money via the central bank. This is of course a quite strong assumption, but I told you that we make quite strong assumptions. So if we say that the central bank can set nominal money and we assume that prices do not adjust, then nominal money over the price level gives us just real money. And so in our model, we also assume that real money, small m, is lowercase m, is also a fixed number. So real money is a fixed number. Oh, there has moved in some German word. So supply is now then assumed to be very easy, just a given number. Money demand, there we use this Keynesian money demand function. Not very surprisingly, since we are still in a Keynesian model, a demand-driven model. And there we just assume, well, that money demand is positively still depending on income, transaction and precautionary motive, and negatively depending on interest rate, again, speculative model or opportunity cost argument. Or if we make then a quite easy assumption, how does this function look like? And if we model this again as a just linear function, then we have the intensity parameter Ly for income. This would be then a positive number, and the intensity parameter for interest rate Li, which then has to be a negative number. In some minutes, we will go through a specific example, and there I will give you then specific numbers for these two parameters. But now if we equate money demand and money supply, then you see also that we obtain a dependence between income and interest rates. Money market equilibrium means then money supply M over P equals money demand L of yi. So this gives us a dependence between income and interest rates. And how this dependence looks like, this we also derive now graphically into diagrams. So here we now start with a diagram, interest rate on the vertical axis and demand and supply on the horizontal axis. And it's a pity, and this we do quite often in economics, that we change just the axis. Again, here we have on the horizontal axis the depending variables and on the vertical axis the independent variable. So let's start with money supply. In this diagram, on the vertical axis interest rates and on the horizontal axis money demand and money supply. How does this money supply function look like? If it's just a fixed number, let's say our 15 trillion euros in the European Monetary Union. Let's say it's the number 15. You have an idea? Yes, it should be horizontal or vertical. And what is? It's a 50-50 question. On the horizontal axis, you have, yes, it is a vertical number. If it's just 15 independent on interest rate, it doesn't matter where the interest rates are. It's always 15. So money supply would look like this. And now we need money demand. Remember, money demand is depending on two variables. But in the right diagram, we do not find our income y. So again, as we have done it in the commodity market, where we have assumed a specific interest rate level, now, in order to draw the money demand function, we at first have to assume a specific income level. So set y equals y1. Then we have just a money demand function depending on y1, fixed number, and the variable I. And here we know that it is negatively that we have a negative dependence between L, money demand, and I. So what kind of function is this then when we want to draw it in the left diagram? If we know that we have here this negative dependence. Yep. Yes, it's a falling function. Then it looks somehow like this. So this would be L of y1 and I. Equilibrium is just the cut of these two lines. So we obtain our equilibrium interest rate level, but this point is depending where we have assumed our income level. So it is depending on y1. And as you see it here, now I also put an income interest rate diagram, but now on the right hand side. Why on the right hand side? Well, I just move with this interest rate level to the right, because then I find it also here. I, star of y1 On the horizontal axis in this diagram, I just put somewhere my assumed income level Y1. So this money market equilibrium coincides then in the interest rate income diagram with this point here. So this point represents one possibility where the money market is in equilibrium. But we again want to have the general dependence. In the commodity market, then we have started to change the interest rate level. In the money market, the parameter we have to change is now the income. So let's assume Y2 is lower than Y1. What happens in the left diagram if we decrease the income level? Remember, the dependence of money demand on income is in general positive. First of all, we have to identify which curve can change. Let's ask at first, does anything change at the supply side? It is fixed, yeah. Still, we do not assume that the central bank is doing anything. So this line is still the same. So then something has to change here with the money demand function. Yes, now we have to move it to the left, downward, because if the income level is decreasing for any given interest rate, we have a lower total money demand. So to speak, every point on our starting money demand function is moving down to the left. So this is then money demand depending now on Y2, Y2 lower than Y1 and I. Then again, we obtain our cut of supply and the new demand function. This is an interest rate level depending on Y2. This put horizontally to our right diagram, I of Y2 decrease of income, so Y2 has to be situated just to the left of Y1, somewhere here. So we obtain a new possible pair of interest rate and income representing a possible equilibrium of the money market. And now comes the general step that we say, well, what happens in the left diagram if we increase income? This would mean that our demand function would shift outward. This would increase then the equilibrium level of interest rates, maybe here. This is depending on a larger income level. This was the starting assumption. So we end up here. Then we ask, what happens if we further increase the income? This would also increase the interest rate again. So somewhere here. Or what happens if we go to even lower income levels? This would mean we obtain some possible interest rate income levels down to the left. And then overall, we obtain an increasing dependence from the money market of interest rate and income, and this we call the LM curve. And this LM curve is the locus of all I-Y combinations where the money market is in equilibrium. Now we have the IS equation or the IS curve, the LM curve. Both are representing that at the one side the commodity market is in equilibrium, on the other side the money market is in equilibrium. So we put both curves together in our interest rate income diagram, and quite surprisingly we obtain then here our cut, and the cut of the two curves is our overall equilibrium of the economy. And at this cut, commodity market and money market are simultaneously in equilibrium. Okay, and now we want to just calculate a simple example given all these functions. At first, we want to determine the IS curve, then the LM curve, and at the last step, the overall equilibrium. Oops. No, there it is. So we will do it analytically and graphically. This will be our YI diagram. And let's start with the commodity market. I have given specific consumption, investment functions, and the level of government expenditure. What do I have to do firstly at the commodity market in order to obtain the dependence at the end of interest rates on income? Yes, I calculate total demand, YD equals C plus I plus G. Inserting our functions is 50 plus 0.8 Y plus 30 minus 300 I plus 20. Let's sum this up. 50 plus 30 plus 20 is 100 plus 0.8 Y minus 300 I. What is the next step? Well, we cannot directly find out the I because from the commodity market, we want to end up with the general dependence of I on income. What are we doing at the commodity market? What is the equilibrium condition? Let's go into our diagram. The equilibrium condition is yd equals y. Because here we cannot solve for y. We have two different variables. Yd and y are at this step not the same. But then comes this very main assumption that we have a demand-driven model that we say, okay, equilibrium condition is that y is equal to yd, that the production y is following the total demand. And then we have y is 100 plus 0.8 minus 300i. And now we can solve this equation for y. Oops, there's one y missing. So minus 0.8y means 1 minus 0.8 times y equals 100 minus 300i. 1 minus 0.8 is 0.2. We want to get rid of this number, so multiplying by 5. Dividing by 0.2 is the same as multiplying with 5. Yes, 500 minus 1500 times I. So, and this is then our IS curve. Now we can draw this IS curve. We know this is a falling function, so setting I to 0 means we have a y of 500. So it is then the cut of the horizontal axis at 500. And then we ask, what is the cut with the vertical axis? This means what kind of interest rate level do we have if y is 0? This would mean 1500i equals 500. Dividing by 1500 is 1 over 3. So here this would be then 33 period 3% is 1 over 3. So this would be then our IS curve. Let's go to the money market. The money market is a little bit easier because here we do not have to calculate at first a total aggregate function, since we directly have given demand and supply. So the equilibrium condition is just M over P. Supply equals L of YI demand. Supply, demand. Let's insert our numbers. M is 400, P is 2. So 400 over 2 equals 0.5 y minus 250 times I. This means we have 200 is 0.5 y minus 250 I. Solving this also for y, means adding 250i. So we obtain 0.5y is 200 plus 250i. Dividing by 0.5 means multiplying by 2. In the end, we have 400 plus 500i. And this is our LM curve. How does this function look like in our diagram? Well, for I equals 0, we have y equals 400. So it's starting here at 400. And then we have to be a little bit careful because again we have changed the description of the axis, that the left variable here, y, is not on the vertical axis like you know it from school. It is on the horizontal axis. We know both functions, the is function and the lm function, are just linear lines. The slope here is 1500. The slope here is 500. But this means since we have changed the axis, the slope drawing this LM function now has to be lower. It has to be a little bit flatter. Yeah? So maybe it looks like this. The LM curve. And this cut would be then our Y star, I star. And this is then Y star. Of course, we want to know these numbers. What do I have to do? I want to calculate now these equilibrium levels of interest rate, I star and Y star. Yes. So overall, equilibrium means equating just in quotation marks the IS and LM curve. So 500 minus 1500 I equals 400 plus 500 I. Subtracting 400 plus 1500 I means 100 equals 2000 I. Dividing by 2000 means I star is 100 over 2000. The two zeros are cancelling. 1 over 20 is the same like 5 over 100. 5 over 100 is just 5%. So this would be 5%. And now I also want to know what is Y star. Yes, I can just put it in the IS or the LM curve or equation. So 500 minus 1500 times 5% means 500 minus 5 times 15. 5 times 15 is 75. 500 minus 75 is 425. Hopefully everything is right, and for this I just inserted in the LM curve. 400 plus 500 times 5%. 400 plus 5 times 5 is 400 plus 25. Okay, 425. Okay, so 15 minutes left. Now comes the interesting part. This is the overall equilibrium. Now we go to Berlin, and there are our politicians. and they are talking about, well, let's change something in our economy. And what we are discussing now in Germany is especially doing fiscal policy, and this would mean we change the variable of government expenditure. About this we have already talked in the pure commodity market model, and now we are doing fiscal policy in this ISLM model. And we ask what happens then. Okay, let's do it at first graphically. And let's think, well, this variable of government expenditure, so to speak, firstly, we see it in the commodity market. YD is C plus I plus G. So something has to happen in the commodity market. Let's now think again, how have we derived our IS curve? Well, of course, this IS curve does not only depend on the investment level, it also depends on the government expenditure level, because YD is C plus I plus G. So the locus where we find total demand function is of course also depending on this government expenditure level. Here we have it. And now we increase this government expenditure level. What happens in this upper diagram? If we increase G, what happens? Yes, so here we want to add our G. What happens then? Which curve is changing? Yeah, it goes up. Yes, of course. And I'm a lazy guy, so let's just copy all this and let's move it upwards. Of course, this is now depending on a larger government expenditure level plus G. Oops. And here also plus G. Oops. 10 maybe. Still too large. Ah, now it's working. So this difference is delta G. So this here was also depending on some special interest rate. Remember the argumentation which we made when we have derived the IS equation. So this level represents this overall equilibrium from the commodity market in our interest rate income diagram. But this of course also depends on the starting level of government expenditure. But now we have an rightward moved overall income equilibrium level of income. So this is or has moved to the right. say this is now a y, oops, 2, oops, 2. How do I come to this 2? And here I also have to add our increase of government expenditure. But here still we have the same interest rate. So this point has then moved to the right. And now we have to go back. Well, now again we have to calculate all income interest rate levels corresponding now to the new higher government expenditure level. So what has happened to this point happens to all other points. So overall, we obtain then a rightward shift of the IS curve. And this IS curve is now depending on this higher level of government expenditure. Well, and now we have to go to the overall equilibrium. We have argued that the IS curve has moved to the right, G plus delta G. This means we obtain a new cut between the LM curve. At the money market, nothing has happened. And we obtain an increase of interest rates, G plus delta G, and an increase of income, G plus delta G. So this means increase of equilibrium interest rate I star and income Y star. Well, of course, this is now only an analytical theoretical argument. Let's try to argue qualitatively what happens in our economy. So we are starting increase of delta G. We know government expenditure is a variable of total demand. So we know, so to speak, in a first step, but be careful, this is a static model. What I now argue in a row all happens simultaneously. It's not a dynamic model, but we can think of what pushes the economy in this case of fiscal policy. So at a first step, this would increase total income via the commodity market. But now we move to the money market. This would also mean increase of income means an increase of money demand. Transaction motive. But an increase of money demand, we have a positive dependence between income and interest rates. LM curve means also that we have an increase of interest rates. interest rate I is going up. This is the argumentation from the money market. But an increase of interest rates feeds back on the commodity market. This means also that I of I, if interest rates have increased, this drops investment. So investment is decreasing. But decreasing is also a component of total demand of Y. So this means that Y is lowered a little bit. But overall, we have a positive netto effect on income. So at first, we have, so to speak, a large impulse, and then it is pushed a little bit back via this interest rate effect. And what we can say here, delta G means an increase of public investment. We are now rebuilding our bridges, investment in digital infrastructure, investment in the railways, harbors, and so on. But from the public side. But this public investment via the money market, due to this positive dependence of the LM curve, means that the interest rate level is increasing, and this is dropping private investment. But this decreases via the increased interest rates private investment I. And this is then called overall the crowding out effect. And there we have to have an idea how large is this crowding out effect. Because overall we want a really positive push. If this crowding out effect would be 95, 99% or something like this, then overall on GDP, we would have only an exchange of government expenditure and private investment. This is called a crowding out effect. And for this, of course, then we have to make these econometric estimations. This especially means how steep is, for example, this LM curve. If it's very flat, then we have a low crowding out effect. If it's very steep, then we have a large crowding out effect. And how large is this crowding out effect? Well, we have argued this horizontal movement of the IS curve. This is just the effect which we would have if we would have only the commodity market working. So this is delta Y only from the commodity market. But then we have this increase of interest rates, So we have then a pushback to this a little bit lower level of total income. So this is delta Y in the ISLM model, and then this would be graphically in our model the crowding out effect. Okay, only 1 minute overtime. Thank you very much for this week, and next week we will then talk about monetary policy, and then we will relax this assumption of fixed prices. See you next week, and participate in the survey that we can fix the postponed lecture. Okay.